So now let's talk about propositional equivalence. Propositional equivalences. So two logical expressions are said to be equivalent if they have the same truth value in all cases. Sometimes this fact helps in proving a mathematical result by replacing one expression with another equivalent expression without changing the truth value of the original compound. So to understand about the propositional equivalences, there are samples on how to distinguish that these two logical expressions or two statements are equivalent. So before we proceed to that propositional equivalences, first let's talk about the types of propositions. So there are three types of propositions: the tautology, the contradiction, and the contingency. So those are the three types of propositions. So the first one is the tautology. So tautology is a formula which is always true. So take note. So tautology is a formula which is always true for every value of its propositional variables. So meaning, if the given formula or the given proposition returns a value of true, all of it is true. So for if you take a look in here in the truth table, so in this formula, so example is prove that, so if A then B, so don't get confused if A and B is different from if B then A. So lahi na siya ha. So nasa kung sa tong first exercise nato, so na ako'y question dito or na ako'y proposition dito na if B then A, then some of you answer it like this. So pagkuha niyo sa truth value, ang pagkuha niyo sa truth value is like this. It's different ha. If A then B is different from if B then A. Again, if A then B, then this operator is an AND. So if A then B and A, then B. So prove that if A then B and A, then B is a tautology. So this proposition. So here are the given values for every variables. So variable A has a values true, true, false, false. Then variable B has a value true, 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 false, true, false. So first, before we proceed to this proposition, so get the return value of this first proposition, if A then B. So this one. So mura siya og gi-breakdown ang formula, gipang tagsa-tagsa siya before i-come up dito sa tibuok na formula na jud. So gi-breakdown siya. So if A then B. So if you still remember the first lesson that we discussed about connectives. So if A then B, so since A and B has the same value of true, so it will return a value of true. So true is equals to true. So once again, if in implications, if both variables have the same value, whether it's true or false, automatically its return value is true. If it's not the same, so the last variable will be the return value. So in here, so A is true, then B is false, so the return value is false since B is the last variable and has the value of false. Then next, A is false, then B is true. So since B has a value of true, then the return value is true. Then the last is both A and B has the same value, then the return value is true. So that's the implication, or if A then B. Then the next proposition, if A then B and A. So since we got the return value of if A then B, so now let's get the return value of this proposition. So first, so since if A then B has a value of true and A, so since A has a value of true, so true and true is equals to true. So once again, in connectives and so if both variables is the same value of true, then it will return a value of true. So since if A then B has a value of true and A has a value of true, then it will return a value of true for this proposition. For next, so he in this proposition, if A then B has a value of false, then A has a value of true since both variables or both doesn't have the same return value or values. So in end, if at least and is opposite to or. So and since both variables or propositions doesn't have the same true value, so automatically ang return niya is false. So the same with the two examples. So since A has false, then if A then B has true, then false. Sa end na siya, then the same here, A is false, then if A then B is true, then return is false. So now let's proceed to this proposition na. So since the breakdown na nato to, so di na ta maglibog. So since this proposition na diri ang return value, ang kuano na nato is ang value sa B. So if true, then B. So since both proposition has the same value, both true, so it will return a value of true. So muna sa simplification ha, if both proposition or both variables has the same value, mapa-true or mapa-false, automatically it will return a value of true. Then the next, so kani gyapon tong lantawon, so since it has a return value of false, then B has a value of false. So parehas naman gyapon siya og value, so the return value is again true. Then next, so this proposition is false. Then in here, the variable B has a value of true. Since B is the last variable, so the return value is true. So sa implication ha, kung dili parehas gani og value ang variables, so ang katong last variable sa if A then B, so kung last variable niya is ang B ba or ang A, so motoy kwaon na value. Then the last, so since both the proposition and the variable B has the same value, so para siya false, so the return value is true. That is the tautology. So tautology is a formula which is always true. So tanan i-return value niya for every value of each propositional variables. So this proposition proves that this is a tautology. So another example for tautology, so I have here a proposition. So this is or and this is biconditional. And another or. See, A or B, biconditional A or B. So A or B, biconditional A or B. So we need to prove that this proposition is a tautology. So first, break down that proposition. So kani unahon na to. So this one. So A or B. So variable A has a value of 1100, then variable B has value of 1010. So A or B. So since So again, sa or is opposite of and. So or if at least one variable has a value of true, then the return value is false. Again, if at least one variable has a value of true, then the return value is true. So since pareho siya, so true. Dire pod naa may true isa, true again. Then dire sad variable b is true, so true gyapon. Then next, so since pareho siya false, so false yung gikuan or zero. Then next, so this kanina pod the proposition natong kwaon. So since nakuha naman nato ang value, so sa ani na proposition na A or B, so proceed ta dire sa if A or B by conditional A. So A or B has a return value of 1, then A has a value of 1. So since it's by conditional, so sa by conditional, the same with implications, if both variables has the same value, whether it's true or false, automatically it will return a value of true. So if you take a look here, so 1 na siya dire, 1 po na siya dire, so the return value is 1. Here na po sa last, 0 dire, then 0 po sa A, so the return value is 1. So the difference between biconditional and implication, biconditional, if both variables doesn't have the same value, automatically it will return a value of false. So since dire 1 ni dire, then 0 ang A, then false. Then dire 1 man siya dire, then 1 po siya dire, then the return is 1. So ingatan by conditional, don't forget those connectives. Then the last, so the whole proposition na. So let's prove that this proposition is a tautology. So nakuha na nato ni. So dire na yung mga return values. So since or B. So 1 1, so 1 or 1 is equals to 1. Then 1 or 0 or so 1 or 0 equals to 1 again. Then 0 1, so 0 or 1, then 1 again. Then 1 or 0 1 again. So this proposition proves that it is a tautology. Sige nga to ang tautology. So the return tautology is a formula that returns all true value of the propositional variables. So that's the tautology. Then contradiction is the opposite of the tautology. So contradiction is a formula which is always false. False po diring napita for every value of its propositional variables. So tautology true, always true, then sa contradiction is always false. So let's prove that this proposition is a contradiction. So prove na to na siya it's a contradiction. So once again, we need to break those proposition. So first, so the variables A, B here, then so the first proposition A or B. So A or B, so true, 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 false, true, false, true, true, then false, false, false. Then not A. So not A is just the opposite value of the variable. So since A is true, then not A is false. So true, not A is false. Or false, not A, or not false is true. Then again, false, not false is true. So that's for not A. Then not B, the same. So what is not true is false. Then not false, true. Then not true, false. Then not false is true. Then the next proposition is this one. So kanina po. So not A and not B. So not A and not B. So first, you get to the value of this proposition not A and not B. So not A is false and not B is false. So since it's AND, so the return value is false. Same here. So AND sa AND basta isa man lang sa ilaha dili true, false automatic. Pero kung parehas variables is true, true na siya. So dire pod since di man siya parehas, false and true. So false, true and false, false, then true and true, true. So na-breakdown na nato ang kada proposition. So now, kato na ang whole proposition ng A or B and not A and not B. So, values, the return value of A or B. So, true. Then the return value of not A and not B. So, true and false here. True and false. So, since the operator that connects these propositions is AND, so, true and false. So, the return is false. Next, again, true and false. So, the return is false. True and false again. So, the return is false. Then, false and true. Then, the return is false. So, this proposition proves that this is a contradiction. So, again, contradiction always false for every value of its propositional variables. Another example to prove that, another example to understand about contradiction. So let's take a look at this proposition. So this proposition, A and B by conditional not A, and if A, then B. So again, first break down the propositions. So A and B. So here are the variables of the A, variable A and B. So 0 and 0. So since both 0, it will return a value of 0. 1 and 1. 1. 0 and 1. 0. 1 and 0. 0. So let's proceed. So these are the return values of A and B. So next, not A. So the opposite value of the variable. So not 0 is 1. So not A. So since A is 0, so 1. Then 1, not 1 is 0. Then not 0 is 1. Then not 1 is 0. Then, so nakuha na nato po na siya. So the next proposition, this. So if A then B. So if A then B, so since A and B has the same value, so the return value is 1. So implication ni siya. Then 1 1 1, then 0 1 since B has the value of 1 1, then 1 0 since B has a value of 0 0. So nakuha na po natin ni siya. So next, kanina po na proposition. So this one. So kuhaon ra nato ni. So, ang return value natin magbase. So, 0 sa by conditional. 0 by conditional 1. So, sa by conditional, once again, by conditional, if both variables doesn't have the same value, automatically the return value is false or 0. So, 0, 1, 0. 1, 0, 0. 0, 1 again, 0. Then, since both variables, both proposition has the same value, 0, 0, then it's 1. Now, let's the final proposition. So, the combination of all the propositions na. So, if A, so A and B by conditional to not A, and if A, then B. So, dire ta magbase. Kanina siyan. Kanina proposition and kanina na proposition. So, if A then B, since 1, dire ta. Then, 0. So, since it's AND, and siya. So, since both variables or both proposition doesn't have the same value in end, so automatically it's 0. So, the same here, 1, 0, 0 na pod, 1, 0 again, 0 again, then 0, 1, 0. So, this proposition, this proposition proves that it is a contradiction. So, contradiction is always false for every propositional variables. So, the third type of proposition is the contingency. So, unlike tautology and contradiction, so contingency is a formula which has both some true and some false for values for every value of its propositional variables. Pasabot sa return value niya sa ana na proposition na ay true, na apoy false. So, combined na iyahag true and false. So, if you take a look in the truth table, so prove that A or B and not A. So, let's prove that this A or B, this proposition A or B and not A is a contingency. So, the variables for A, true, true, false, false. For B, true, false, true, false. So, here, A or B. So, since A or B na siya, not A and B, so, just look at the values of the variables. So, true, true, true or true will return value of true. Then, true or false, still true. False, true. False or true, true again. Then, false or false, false. Then, not A. So, not A, not true. So, it will turn false. Not true again, so false. So, not false is true, then not false is true. Then, the whole proposition na. So, A or B and not A. So, again, contingency is a combination of true and false. Some true and some false. So, lantaon lang nato ning kaning return value ani niya og ani niya. So, true and true. So, false. True and false. False again. And then true and true. True. Then false and true. False. So, that's contingency. So, a contingency, so a combination of all or combination of both true and false. So, I have here another example. So, let's prove that this proposition is a contingency. So, again, this is exclusive OR. So, it is a 0 or O with a cross inside. Again, by conditional, you can write by conditional like this. Pwede rin nga na. Pero, ang implication, you can never write it like this. Dili pwede ana ang. So, implication is an arrow pointing to the right. So let's prove this proposition. So, first things first, break down the proposition. So, exclusive OR. So, in exclusive OR, it is the opposite of biconditional. So kung sa biconditional, kung if both variables has the same value, whether it's true or false, so the return value is true. Then, if doesn't have the same value, the return value is false. So, sa exclusive OR, it's the opposite. So, sa exclusive OR, if both variables have the same value, then the return value is false. If it doesn't have the same value, then the return value is true. So, you can look here sa truth table na makita nyo na A exclusive OR B. So, both variables has 1. So, the return is 0. Then, the next, 1, 0 na siya. So, return is 1, 0, 1, 1, then 0, 0, 0. So, not A. So, what is not 1? So, 0. Not 1 again is 0. Not 0 is 1. then not 0 is 1. So, if A then B, so nakuha na natin siya, nakuha na siya din kanina. So, if A then B, so again, don't get confused. If A then B is different from if B then A. So, if A then B, 1, 1, so the same value, 1. 1, 0, so 0. So, since B is the last variable, then 0, 1, 1, then 0, 0, 1. Then, this proposition na the combination of A or B, exclusive or A or B by conditional, not A. So, tanaw lang ninyo na siya dire, ang truth value ani, then ang truth value ani, then by conditional operator. So, 0 by conditional to 0, 1. So, since both variables, both proposition has the same value. Then next, 1 by conditional to 0, so 0. Then 1 by conditional to 1, 1. Then 0 by conditional to 1 is 0. So, nakuha na nato ni. So, kanina, last. So, ang atong lantawon is this proposition and this proposition. So, the return value of this proposition and this proposition. So, 1, 1, exclusive OR. Ay, mali. Why this is... This is 0, by the way. This is 0. Baliktad. So, dapat kani siya 0 ni siya. Then, this is 1. Nabaliktad na ako. So, since 1, 1, exclusive OR again na. So, pag parehas og values, so, 0 siya. Pero pag dili parehas og values, 1. So, 1, 1, that is 0. Then, 0, 0, 0, 1, 1, 0, then 1, 0, 1. Okay. Yan na ang contingency. So, kung i-compare nimo ang tulo, so mas dali ra ang makahimo ka og it's easy to create a proposition if it's contingency. Unlike tautology and contradiction, kinahanglan pa nimo hunaon og ayo ang formula or ang proposition para ma-sure jud nimo na ang iyang i-return value kung sa tautology true, then sa contradiction is false. So that's the three types of the proposition. So now let's talk the propositional equivalence. So propositional equivalence is if two statements X and Y or two propositions are logically equivalent if any of the following two conditions hold. So there are two conditions na kinahanglan mag-contain ana na statements or ana na. So again, so propositional equivalence, two statements or two propositions X and Y are logically equivalent if any of the following two conditions hold. So the first condition, the truth tables of each statement have the same truth values. So whether sa kung kani siya na process, the first proposition and the second proposition, even they have different proposition, so but the return values is the same, so pasabot ana propositional equivalence na siya. Then another condition is the biconditional statement of those two proposition is a tautology. So bale kung katong duha ka proposition, ang iyang mga return values are all true. So let's take a look here. So let's prove that this proposition is a propositional equivalent. So this proposition, so let's say this is X, proposition X, and this is the proposition Y. So let's prove that these two propositions is a propositional equivalence. So kinahanglan ma-meet to niya tong conditions. So the first condition is that they have the same truth values. Then the next condition is by using the biconditional, they have they will return a value tautology, or every values returns a true value. So if you take a look here at this truth table, so i-prove na to ning kaning proposition na not A or B is is equivalent to not A and not B. So see here, so the values for the variables: A true true false false, and B true false true false. So A or B, again A or B, so true true, true or true, so it will return value of true. Then true or false, true again, false true, true again, then false false false. The next proposition, so the first proposition, or so not A or B, not A or B. So first things first, kao na to ang kon ani. So muna ni siya. So si A or B, so the return value of A or B sa first example is true, then you negate it. So not true is false. So yun nga to unahon ng nasa parentheses. So not true is false, then not true again is false, and not true again is false, then not false is true. So muna siya. So kanetong lang tawon, because this is the first proposition. Then before ta na, so i-break down sa nato. Not A, so dire. So not true is false, then not true again is false, not false is true, and not false is true. Then next, not B. So direta sa values of B. So not true is false, not false is true, not true is false, then not false is true. Then let's prove na po ang let's get the truth value of this proposition. So we have to be sure that the return value of this proposition is equivalent to the return value of this proposition. So not A and not B. So not A and not B. So direta maglantaw sa return values nila. So false and false. So since it's and, so false. Then false and true. False again. True and false. False again. Then true and true. Return is true. So if you take a look of this proposition and this proposition, the return values is equivalent. So false, 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 true. Then false, 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 true. So meaning these two propositions, the not A or B and not A and not B, are propositionally equivalent. So that's the first condition. So kinahanglan the same siya og return value sa truth table. So another condition po niya is kung tautology siya using the biconditional method. So this same proposition, so this is the proposition X and proposition Y. So we have to prove that this proposition pod is a propositionally equivalent dayon gamitan siya by conditional. So meaning in propositional equivalence, so using the same propositions, so only the same two propositions that meets the two conditions. So let's take a look here. So again, dire. So kung dito sa primero murag breakdown nato, dire murag kuan na siya. So it doesn't matter kung i-breakdown nimo or dili. Importante you have just need to prove that these two propositions is propositionally equivalent. So dere, so not A or B. So first kaon ang dere. So A or B is true, then since not, you're going to negate it, so false. Then true or false, true again, negate, false. False or true, true again, negate, then false. Then false, false, it's false, then you have to negate it, then the return is true. So that this is the return value. So muna na siyang first proposition. So the next proposition, the not A and not B. So not A and not B. So not A. So not true is false. Then not true is false. So A and B. So false and false. So the return is false. Then dire na po, false and true. So not ha, negate siya, negate. So false na ni siya, then kani siya true. So false and true, then false. Dayon, true and false. So false. So negate na nako siya. Dayon, true and true. So the return is true. So muna po na siyang next proposition. So since we have to prove it that these two propositions are equivalent using the biconditional method or the biconditional operator. So here is the proposition, the not A or B biconditional to not A and not B. So kuhaon na to ni. So false, then biconditional to false. So again, the same value. So the return is true. Then false and false again. False biconditional to false, true. Then false, false, true again. Then true, true, true again. So meaning this true proposition is also propositionally equivalent because the second condition meet. So using the biconditional, it has to return a total all values of true or a tautology. So again, the first condition, so kinahanglan both statement have the same truth values. Then the second condition, using the biconditional, so it should return a tautology or all must have a true values. True values. So dire tautology na siya. So napasabot. So this proposition is logically propositionally equivalent. So again, so to prove that the two proposition is propositionally equivalent, so it has to meet the two conditions. So it should have the same truth value and it should return a tautology using the biconditional operator. So that's about the propositional equivalences. So predicate logic. So when propositional logic fails, so this is the time that the predicate logic inserts. So predicate logic, predicate is an expression of one or more variables defined on some specific domain. Then a predicate with variables can be made a proposition by either assigning a value to the variable or by quantifying the variable. So pasabot ani niya na ang predicate expression da is defined by a specific domain or a also called the domain of discourse or the universal domain. So then a predicate with variables can be made a proposition by either assigning a value to the variable or by quantifying the variable. So the predicate can be a proposition if you going to assign for its value. So and using a quantifiers. So here are the examples of predicates. So let uh, let e of xy or denoted by x is equals to y, then let x a b c denote by a plus b plus c equals to 0, then let m x y denote by x is married to y. So these capital letters e, x, and m, these are the predicates. So predicate, it is that is the predicates, the capital letters. So E, X, and M. It can also be P or any letters of the alphabet, as long as it is written in uh no, it's written in uppercase siya, or capital letters ang pagsulat. So those are the predicates. Then the small letters, which is inside the parentheses, are the variables. So if you can see, so predicates has a parang mura siya og gibahi parts. So the the variables, predicate the variables. Then if you can notice, so these predicates, that one and that also one, are called propositional functions. So kay mura siya og nakaporma na function. If you still kung nakakuan mo sa inyo C++, na ingana ang porma sa function na sa tawag na a function, then its arguments or parameters. So mahulog siya kani ang function, then kani ang mga parameters sa sulod. Pero in here it is the predicate and the variables. Then propositional functions is not a proposition unless their variables are each replaced by a value from the domain which is denoted by you. So pasabot, these statements are these propositional functions is still not a proposition, not unless you replace these variables with value from the domain, or which is denoted by you, or domain, you can say that domain of all integers. So para mas masabtan nato ning kuan about predicate logic or about predicates. So again, I have example here. So let p of x, so p is the predicate, then x is the variable. So denote x is greater than 0. So meaning kung sa function pa, so ang function sa p of x is x greater than 0. So and the domain or the universal or domain of this course is are integers. So here the propositional functions is a proposition since the variable x has a value. So for the first example, so p of x, which is x has a value of negative 3, so is false. Why? Because is negative 3, so negative 3 greater than 0? No. Because basta negative na gani na, below 0 na siya. So kana ang inyong kunin yung kanon para ma-prove ninyo na so 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 this predicate has a return value of false since negative 3 is not not greater than to 0. So next predicate, so now x has a value of 1. So is 1 greater than 0? So yes. So it will return a value of true. So dire false because all negative numbers is less than to 0. Then here is 0 greater than 0. Also false because 0 is equal to 0. So since the predicate na to is x is greater than 0. Sing ana ang predicate. So ang predicate, it's like the same with propositional function, but the propositional function is not a proposition, or you will not get a return value not unless the variables are given a value from the domain of this course. So I have here a more complex type of predicates. So in these predicates, it uses the connective. So makita ninyo na ay or, na ay and, then na ay implication, then na po yung negation. So still, P of x denotes the x is greater than 0. So let's find the truth values of these predicates. So first things first, unahon na to ni kanina predicate. So is 3, so 3 now, or x has a value of 3. So is 3 greater than 0? So true. So next, the next predicate, katong kwaon, is negative 1 greater than 0? False. So since the operator or the connective is or, so t or f. So the return value of this is false. Ay, true rather. So the return value is true. So this predicates return value is true. The next, so dire na po ta. So 3 is greater than 0. True na po. And P of negative 1. So since negative 1 is less than 0, so T and F na siya. So since the connective is N. So since it's N, so the return value is false. So end ha, basta kan gani sa end, false na siya kung dili parehas true. Then the implication, dire na ta. So 3, dire ka na gyapon kuan na to. Is 3 greater than 0? It's true. True again. Then is negative 1 greater than 0? So false. So implication man, so if if true, then F. So since implication, so the return is false. So since F is the last variable. Then here is 3 greater than 0. True again. Implication is negative 1 greater than 0. It's false. But since it has a negation, then the return value of that is true. So if true, then true. Then since it has the same value, then the return value is true. So ana siya ang ana siya ang about predicate logic. Now let's proceed to quantifiers. So quantifiers, or those are it's a operator or prefix operators na that binds the variables of a logical formula. So quantifiers, the variable of predicates is quantified by quantifiers, and quantifiers has two types two types of quantifiers in predicate logic. So again, so quantifiers, it's an operator that is a prefix operator na pasabot na kauna na siya. So, unahan na siya sa every formula. Then the two types of the quantifiers are the universal quantifier or denoted by the symbol inverted A, so baliktad siya na A, and then existential quantifier which is denoted by baliktad na E. Baliktad na E. So, two types of quantifiers, the universal and the existential quantifier. So, the first is the universal quantifier. So, universal quantifier states that the statement within its scope are true for every value of the specific variable. So, if you take a look here, so pagbasa niya is for every or for all value of x, px is true. So, sa universal quantifier, so the universal quantifier is true are true for every value of the specific value. So since kinahanglan po nimo ni siya murag you need to get also the return value of this quantifier. So pagbasa niya is for every or for all value of x, px is true. So let's sa example here, man is mortal. So, man is mortal can be transformed into a propositional form for all x, p of x, where px is the predicate which denotes x. So, x is mortal and the universe of discourse is all men, or the domain is all men. So, meaning, so this quantifier for all x, for all x, px is true because all men are mortal. So, the domain or universe of discourse is men. So, pasabot, the variable x, which is mortal, then the universe of discourse is men. So, pasabot, this will return a value of true. So, since universal quantifier states that the statements within its scopes are true for every value of the specific variable. So, nga na ang universal quantifier. All true ang iyaga. Mura pa siya tautology. So, let's take a look at here. So, let p of x denote x greater than 0. Find each truth value for all x, px, p of x. So, let's say, u is denoted by the domain or the universal domain. So, let's say u is z. So, z are integers. Tanan z. Z represents tanan integers. So, tanan integers mo pa negative or positive. So, all we need to do that this thing is will return a value of true is just you're going to found a counter example. Namura na siyang example na pamatuod lang na kani siya will return a value of true. So, let's say, so since the predicate is x is greater than 0, so then z is all integers. Pasabot negative or positive. So this prove that this is so this quantifier or will return a value of true. So let's say negative 1. So negative 1. So ang x or the integer. So negative 1 is negative 1 greater than 0? False. So meaning, therefore, this quantifier for all x, p of x, is false. So meaning, this for this example, the domain which is all integers, be it negative or positive. So this proves that this quantifier for all x p of x is false. So ingana ra sa inyong buhaton para mabikil or makita mo og proof na kani siya nakuan is ay true or is a false. So if you take a look here in the second example, so again z is the represents the integers. So dire z all positive integers since na siya plus. So all positive integers ang pwede ra magamit ani. So let's say positive integers man. So let's say 1, 2, 3, 4. So those numbers higher than 0 is or is greater than 0. So meaning this statement here or this example here is true. So therefore p of x for all x p of x is true. So meaning kani siya nakuan once na kuan lang positive siya. So for all x p of x is true. Basta kuan lang. It also depends with the predicates. So kung lahi po na siya na predicates diri, lahi po ang iyong ikuan. So lahi po ang kuan. It might this pwede kanina siya na example diri. So for all x p of x is true. So it depends on the predicate. So next is the existential quantifier. So existential quantifier states that the statements within its scope are true for some values or of this specific variable. Kung sa universal quantifier, for all kan siya, for all values dapat true. Then sa existential, for some. So there are some values na true siya. So it's the symbol is an inverted E. So it reads as for some or there exists. So for some or there exists value of x, p of x is true. So if you take a look here of the example, some people are dishonest. If you translate it into a propositional form, there exists x p of x where p of x is the predicate which denotes x is dishonest, so the value of x is the dishonest, and the universe of discourse or the domain is some people. So meaning there are some people who are dishonest and there are some people who are honest. So muna nga na sa existential quantifier for some or there exist, sa universal for all. So if you take a look here, so the same sample dito lang, and the kalahian lang dire negative na siya. So let's prove that let's find the truth value of there exists x p of x. So p of x denotes the x greater than 0. So let's say again dire all integers. So all integers na po siya. So u is so the universal domain is z. So z represents all integers. So again, let's find a counter example. So let's say 3. Is 3 greater than 0? Yes. So therefore, so true na siya. True. So therefore, there exists of x, p of x is true. So pasabot in this example, kani siya na example, this p of x returns a value of true. So some process or kandiya na this quantifier or this proposition returns a value of true. And if we take a look in this next example, so in this example, the universal domain, which is represents to all negative integers na. So, negative integers. Since negative integers, mas akong yun kaganyan, all negative integers are below 0. So, pasabot ana. So, this returns value of false. So, therefore, there exists x, p of x is false. So, bale, dili na siya, mara siya og kanang dili siya an exact example for this proposition. So, ingato ang for some and for all, or the universal quantifier and the existential quantifier. So, let's take a look here. So, let's have a practice. So, let p of x be x plus 1. So, ingani ang niya. X plus 1 is equals to 2x if the domain consists of all integers. So, let's find the truth value. So, the domain is all integers, be it negative and positive. So, let's prove that this is a true or conjugate niya siya. So, let's prove na. So, by using the counter example again, mura na siya parang pangbikil kung kani ba siya for all ni siya, for all for all x, p of x is true. So, kung makakita mo bikil na dili ni siya ma-prove na for all x, p of x is true, then, okay. So, gamitan yan na predicate. So, for all x, p of x is true. So, let's find a counter example that proves that this for all x, p of x is true. So kung makainom daw pa masin yung algebra, so x plus 1 equals to 2x. So, mangitataog value sa x na maka-prove na kani siya is maka-return value of true. So, maski sa lang na value. So, x plus 1 equals to 2x. Sige. So, give me a value of x. Ma-positive ba na o negative? So, give me a value of x. 1 plus 1 equals to 2 times 1. So, 1 plus 1 equals to 2, then 2 times 1 equals to 2. So, true siya. But, since it is for all, it's universal. So, dapat, kung ang kuananan niya is, kung sa p of for all x, p of x, dapat ang kuan niya is, kung ang p of x1 and then p x2, then end na pod, then so and so forth. So, kung makainom mo sa end, so, dapat true na siya tanan. So, kung true ni true po sa sunod. So, for first example na to, sa naka-return siya og true. So, another example na pod. For all ni siya, for all. So, another example. So, give me another value for x. 3 plus 1 equals to 6. Diretso na to, 6. Dayon, 4 equals to 6. So, since this false, so, pasabot, so, the return value of this, so, therefore, this proposition for all x, p of x, is false. So, meaning, dili siya kuan. Dili siya true sa tanan kuan niya. Uy, shit. Dili siya true sa tanan return value niya. So, dapat mangod sa for all, ingani siya. And so sa for all mangod, dapat ang first predicate or first value is true, then and second value is true, and the pod true hantod sa mokuan. So meaning, so this proposition for all x p of x is false. So nga na ang sa proposition, since ang ato mangong gigamit na domain is all integers. So let's prove the same predicate. So there exists. So let's say, so there exists ba na p of x is true. So let's use these values. So let's use these values. So 1 is x has a value of 1. So 1 plus 1 equals to 2. Then 2 times 1 equals to 2. So since true, so there exists x, p of x. So it's true. Again, existential quantifiers returns it means that proposition returns a proposition that some values are true. So nga na ang sa there exists. So kung lantawon ninyo, medyo complicated ang pagkuha og true value for the quantifier, a universal quantifier. Kay you have to make sure that ang given nimo na predicate will return a value of true. Okay, for all good siya. For all x, p of x is true. Unlike sa existential quantifier, at least nalay isa ang mag-return og true. So kung gamitan nato na siya connectives sa for all, ang iyang connectives is the end connective. The end connective. Then sa existential, ang iyang connective na dapat gamiton is the or connective. Nga na siya ang koan. Nga na siya ang angay lang ninyo timan-an sa universal quantifiers and sa existential quantifiers. So sa universal, gamitan nimo siya end connective para makakuan siya og truth value na true tanan jud siya, true tanan. So dapat from the first example or first variable sa predicate, true na siya, then throughout the sum variables of the predicate, dapat true pod iya ang i-return na value. Unlike sa existential, so at least one man lang, isa or duha ang maka-return value of true.